8-6, all about vectors. And unfortunately, we have a repeat of our math humor.
That's because we wanted to make sure you knew it was right.
What's the difference between a teacher and a triangle?
The teacher is always right.
Darn tootin'. All right, let's do vectors. This always makes me giggle because I don't know how many of you have watched Despicable Me, but he's vector and he goes magnitude and direction. Okay, so this makes me giggle just because I know what vectors are and how to use them. So hopefully it'll make you giggle the next time you watch the movie too. All right, so vectors. The speed and direction of an object can be represented by a vector. Okay, so the vector is simply a quantity that has length and direction, magnitude and direction. Length is considered the magnitude. Okay, but you can think of a vector as a directed line segment. The vector below may be named vector v. Okay, so you could name it with simply the vector if they give it to you. So you could name it vector v, and I want you to notice the symbol for a vector is kind of like an arrow, but we don't have the other side. Now you could also name it with your initial point going to your terminal point. So we could have named this vector AB. All right, we can also name a vector using something called component form. The component form is like this, xy, kind of looks like a point, but it has these arrow-looking things at the end. This is component form of a vector lists the horizontal and then the vertical change from the initial point to the terminal point. So if you take a look here at vector CD from our initial point to our terminal point, horizontally we move 2, vertically we move 3, so the component form of this vector is 2, 3. Now, I'm going to star this. You need to be careful. Okay? This is not slope. Slope, remember, is rise over run. Here we're doing the run first, then the rise. It's the opposite of the slope. So component form needs to go horizontally first, then vertically from the initial point to the terminal point. All right, so writing this in component form, you first have to figure out where do I start? Well, my initial point here is at H. My ending point here is at G. So component form, remember, starts with these little arrow thingies at the ends. Now my horizontal change here is a -3, and my vertical change here is 5. So my component form for the vector HG is -3, 5. Okay, you can also use our points from our our initial to our terminal point to help you find your component form. Now remember, it's horizontal, then vertical. So it's not the change in y, the change in x. It's x goes first. So we're going to take and we're going to subtract our x's. So 2 minus a -8, -7 minus 1. So this is a 10, -8 movement. All right, so here's that cool, fun word, magnitude. The magnitude of a vector is just simply, it's a fancy word for length, okay? So the magnitude is actually written with an absolute value. So if I'm still talking about that cool vector that I showed you that looked like this, where it had A and B in the beginning, and we got vector V. So the magnitude can be written like this. The magnitude of AB with a little vector above it, or V. Okay, this talks about the length of our vector. When a vector is used to represent speed in a given direction, the magnitude equals the actual speed itself. It's the length, it's the speed itself. For example, if a vector represents the course a kayaker paddles, then the magnitude is actually what the speed of the kayaker is. All right, so now I want you to draw the vector -1, 5 in the coordinate plane, and I want you to find its magnitude to the nearest tenth. Okay? Well, they're telling you that the vector is -1, 5. So we start at our origin here. Remember, it's horizontal distance of -1, and then we go up 5, 2, 3, 4, 5. Boop. So this is our starting point, our initial point, and our terminal point. So this right here should be what your vector looks like. That's the vector -1, 5. And now they want you to find its magnitude. Well, we start at 0, 0. We end at -1, 5. I just showed you how to find the magnitude, okay? It's just like finding the length. We take the square root, and then we'll have what? -1 minus 0, oops, squared. Sorry, guys. And then we'll have 5 minus 0 squared. So this is the square root of what's 1 squared and 5 squared. So we have 1 plus 25, so it's the square root of 26. Okay, so the magnitude to the nearest tenth, we're looking at about 5.1. All right, so we also have direction. Remember, it's speed and direction. The direction of a vector is the angle that it makes with a horizontal line. This angle could be measured clockwise from the positive x-axis. So the direction of this vector, AB, in this case, here's my horizontal, the direction is going to be 60 degrees. Okay, the direction of a vector can also be given bearing relative to the compass, so north, south, east, and west. So if we're looking at this picture here, vector AB has a bearing, oops, that's an awful B, has a bearing of north, so it's going north, and then from that, excuse me, from that axis, it's actually going 30 degrees. So it opens up 30 degrees from north, so it's facing north and going 30 degrees, and now 30 degrees, we tilt off to the east, so it's north, and then 30 degrees east. All right, so it says, the force exerted by a skier is given by the vector 1, 4. Draw the vector, and then find the direction to the nearest degree. Okay, so we're going to start putting things together here. First things first, you guys should know how to draw this vector 1, 4. So here's my initial, I go 1, 4, there's my terminal. Draw my vector, oh that's awful you guys. There we go. So there's my vector 1, 4. And now they need a direction, which means they need an angle measure. The easiest way to do this, you guys, is create a triangle. If we use a right triangle, we should be able to figure angle measures using our trigonometry. I know that this is... All right, two vectors are equal vectors if they have the same magnitude and direction. So if they have the same length and they're going in the same direction. Okay? Equal vectors do not have to have the same initial point or terminal point. Two vectors are considered parallel if they have the same direction or if they have opposite directions. They may have different magnitudes, but equal vectors are always parallel vectors. Okay? So, I want you to star this. Equal vectors are always parallel vectors. Okay? Remember, they could have the same direction or they could have the opposite directions. They don't have to have the same directions. I want you to look at the picture here. And they could also have different magnitudes. All right, so looking at this picture, I want you to identify equal vectors. Remember, in order to be equal vectors, we have to have the same magnitude, so they have to have the same length, and we have to have the same direction. And if you take a look, the only two that have the same length and the same direction are this one and this one. Okay, so JI and PO are only equal vectors. Remember, equal are always parallel. Okay? All right, so then parallel vectors, well, I do believe we have two sets. First of all, we know that this is one of them because they're equal, so therefore they have to be parallel as well. But we have another one. If you take a look here, they're going in opposite directions, but they are parallel, and it's okay to go in opposite directions. So we have KL and MN also being parallel. All right, make sure you come with your questions tomorrow, you guys. Have a great night.